Today you'll be solving equations with exponential exponents. A couple things to keep in mind from what you have learned in the past. If I have the nth root of a, that is the same thing as saying a to the 1 over n power. Okay, so for example, if I have the square root of 7 all raised to the 3rd power, that's like saying 7 to the 3/2 power. Also remember, if you take an even root, you need a positive and a negative answer. So because I can do positive 2 squared, right, to get positive 4, and I can do negative 2 squared, that also equals positive 4. So I need this plus or minus if I'm doing an even root. So if we look at our first type of problem, the first step we're always going to do is we're going to isolate the power. So I have to ask myself, how do I get the exponent completely alone? Well, you're going to subtract 5 on both sides for starters, and we'll have 2x to the 4/3 power equals 1,250. And then we ask ourselves, okay, is the power completely isolated? And the answer to that question is no. We can still divide both sides by 2. And so it looks like we'll have x to the 4/3 equals 625. And now our exponent is completely isolated. So our next step is to raise both sides to the reciprocal power. So the reciprocal of 4/3 is 3 over 4. So we will raise both sides to the 3/4 power. So notice we just have x to the 1st on the left side. Now remember, whatever's in the denominator of the exponent is the index of the radical. So we'll have the 4th root of 625 all raised to the 3rd power. Now it's important to note that because we are doing an even root, we will need a plus or minus in our answer. But we have to break down 625. We know if it ends in 25, we can divide it by 25. And I think of how many quarters are in $6.25. Well, there are 25 quarters. Okay, and 25s break down into 5s. Now, because we have a degree of 4 here, I have to have 4 of the same number in order to come out of that radical sign. So we'll have x equals plus or minus 5 all to the 3rd power. Okay, and so we'll have x equals plus or minus 125. Okay, now the next step is to check for extraneous solutions. So what that means are solutions that do not work when you substitute them back into the original. In this case, if I were to use the calculator and I would push 2 and then parentheses 125 to the 4/3 and then plus 5, it does equal 1,255. And the same thing is true with negative 125. I want you to take a minute or two and try the example you tried. Okay, so in this case, we get the same solution. We do get x is equal to plus or minus 125 because we are doing an even root. Okay, so let's look at another problem. We're going to follow the same steps that we did before. So the first thing we'll do is we'll want to isolate that exponent as much as we can. And it looks like we can subtract 2 on either side of the equation. So we'll drop the x minus 4 to the 2/5 power, and it will equal 25. So because the exponent is as isolated as we can get it, the next step is to do the reciprocal power of 2/5. So in this case, the reciprocal of 2/5 is 5/2. So we will do the 5/2 power on either side of the equal sign. On the left side, we'll have x minus 4 equals, now notice we're going to do the square root of 25 and then raise it to the 5th power. Now remember, it is an even root, so we need a plus or minus in our final answer. So we'll have plus or minus 5 to the 5th power. Okay, and 5 to the 5th power is 3,125. Now, to solve for x, I forgot my plus or minus. To solve for x, we will add 4 to both sides. Okay, so we'll have x equals 4 plus or minus 3,125. Remember to give me 2 numeric solutions, however. So I want you to do 4 plus 3,125 to be 3,129. And I want you to do 4 minus 3,125, which would give us negative 3,121. And in this case, this one does actually work. Both solutions are good. So we're ready to roll on. I want you to take a minute or two to try the example you tried. Okay, so in this example, you will get x to equal -1. Notice our reciprocal power that we talked about earlier of 3/2 is 2/3. And because the denominator is a 3 and it is an odd number, we do not need a plus or minus in our final answer. So the cube root of 8 and then squared is just 4. And then when you subtract that from 5, you do get -1. Okay, so in our last type of problem, notice we're going to follow the same steps again. We want to isolate the variable as much as we can before we deal with the exponent. So in this case, what we will do is we will divide both sides by 2 first. So we'll have x to the 4/5 equals 16. Okay, now just like we did before, we are going to do the reciprocal power of 4/5, which is 5/4. So we'll have x equals, we'll have the 4th root of 16 all to the 5th power. Now, because it is a 4th root and it is an even root, we will need a plus or minus in our final answer. And the 4th root of 16 is just 2. So we'll have x equals plus or minus 32. And guess what? Both solutions work when you check them in a calculator. I want you to take a minute or two to try the example you tried. Okay, so in this case, you will get x to equal plus or minus 64. And remember, you need that plus or minus because you have an even denominator in your exponent, which means you have an even root. Time to practice. The end.